Okay, so good evening, everyone, and welcome to CyberSoc Spotlight for December. Today we are joined by Professor Pete Burnap, Amir, and Irene, who are all active in the Cardiff University research sort of space. So they're going to tell you all about research and potentially answer a few of your questions. What are PhDs all about? What sort of other research opportunities are available to you while potentially you're an undergraduate? And where that research may lead you after university, and the sort of doors that it may open for you. So without further ado, we will jump straight over to Pete, who has a few slides to sort of go through, and he will start the session off for us. All right, so I'll just stop sharing mine.
Brilliant. Cheers, Jack. Right, so share mine. I want this one. See that okay? Yeah, good. Brilliant. So thanks for joining, everyone. Yeah, so as Jack said, I'm here today with Irene and with Amir, who both did. So Irene did an undergrad in computer science at Cardiff and then moved on to a PhD. Amir did his master's and moved on to PhD, and they're both sort of still actively involved in the research side. I'm Pete Burnap. I head up the research centre at the university. And I'm going to give basically an overview of what we do, what we're about, what type of research we do. I've got some sort of thoughts around why I think it's valuable to do a PhD. Give you some idea of how you can get involved in a PhD. Then Irene has sort of put together a few questions that she thought she would like to know if she was in your shoes before starting a PhD, which I'll attempt to answer sort of live, and then Irene's going to share a few Mentimeter slides to try and capture your questions from people on the call. Then I'll answer those and then hand over to those guys. So Irene will give a sort of a perspective from her side, so coming through undergrad into PhD and why she thinks it's worth doing a PhD. And then similarly, Amir will do the same, and then we can have some open discussion and all that sort of good stuff. So without further ado, I'll make a start. So right, so cybersecurity landscape. I'm sure most of you are aware we have a national cybersecurity strategy in the UK, which is basically to keep the UK safe and resilient to cyber threats. The UK also has an industrial strategy, which has a number of sectors within it. These are areas of that the UK government essentially says we've got competitive advantages in, one of which is artificial intelligence and the data economy. So essentially part of the National Cybersecurity Strategy was to stand up the National Cybersecurity Centre, which is basically the public-facing arm of GCHQ. They have a remit to also keep the UK safe, and they also do active cyber defence. So in terms of how we bring all that around and together at Cardiff Uni, we do a lot of stuff using machine learning generally, but as a subset of AI, to do threat intelligence and situational awareness. So we've got a strong focus on sort of data-driven machine learning detection of cyber attacks, which then helps the National Cybersecurity Centre, and I'll work with those guys keep the UK safe and secure. So that's the sort of wider context, if you like, of what we do. So Cardiff Uni is recognised on that basis. So the NCSC have 19 what they call ACE Academic Centres of Excellence in Cybersecurity Research. So Cardiff Uni is the first and only academic centre of excellence in cybersecurity research in Wales, with that strong focus on sort of data-driven cybersecurity. So this slide is basically the whole research centre on a slide. It's a bit messy, but it basically captures everything on one slide to save you having to sit through many slides. So bear with me and I'll talk you through it. Right, so basically we're a team of about 50 researchers. So we've got 17 academic staff, so those are permanent staff, 9 postdocs, so people that have sort of finished their PhDs and are doing active research, and then 24 PhDs who are sort of getting to grips with how to do research and becoming independent researchers themselves. So quite a big group. About half of all of that sits within computer science, but the rest of it sits all across the university. So we've got a whole bunch of people in criminology, people in psychology, and people in law and politics. And I'll talk you through where all of that sort of pulls together through this sort of blue block diagram. So some of the areas in which we research, I'll start on the left-hand side of the blue block diagram. So risk assessment and modeling. So typically risk assessment is done through sort of identifying all your assets, looking at the vulnerabilities of those assets, threats that might exploit those vulnerabilities, and then deriving an impact score. That tends to sit in a spreadsheet and is often then used for things like ISO compliance, but is got a couple of limitations. One, from a cyber perspective, you can hardly ever predict everything that's going to go wrong, if you like. So you can't always capture all those threats. The second thing is, and in that context, you can't always use such a risk assessment to understand how things are likely to impact you as an organization. So if a certain part of your system gets taken out, how is that likely to impact other parts of your system? So we do a lot of work around sort of goal-oriented risk modeling and trying to work out, rather than what could go wrong, what we need to go right, and then try and understand the cascading impact of that. The bit in the middle is about risk communication, governance, and collective decision making. This is where a lot of the criminology stuff comes in. So it's around who talks to who around cyber attacks. How do we put in place policies? How do we ensure alignment to those policies? And it's also some of the area around psychology. So how do people make decisions under pressure? Why do people make risky decisions, etc.? The third pillar is then the AI-driven, data-driven software and behavioral analytics. So we do a whole bunch of stuff around detection of cyber attacks using machine learning-based attack detection. So Ami will talk later on a little bit around that. So he's done some stuff around predicting drive-by download attacks from the web using machine learning. Irene's also done a bunch of stuff around this, so detecting attacks on IoT and also operational technology, so stuff that runs factories and critical infrastructures. I'll also show you an example in a bit around how we've used advances in artificial intelligence and neural networks to predict ransomware very early on and sort of grab it and kill it to prevent file encryption. And we do a lot of this in the context of emerging tech. So if you look at the sort of arrow going from top to bottom, emerging tech examples are IoT, cloud. We're now moving into automotive as well. So we're interested in all of these things from a perspective of emerging tech. If you look at the arrow that comes out of the AI data-driven software behavioral analytics bit, you'll see it links all the way back around to the risk assessment. So this is an area that we're very active in at the moment, which is basically saying if you've got machine learning or an AI telling you that an attack is imminent or is underway, how do you actually use that to do anything? You know, it's all well and good putting an alert up in a SOC or a SIEM, but we actually want to be able to do something with it. So we're working on methods that you can take the outcome from a machine learning based approach or an AI and feed that into your risk assessment so that it dynamically tells you, you know, you looks like you've got this ransomware attack on this particular device, which is part of this subsystem. And if this spreads, it's going to impact subsystems X, Y, and Z, and the impact is likely to be, you know, whatever it might be. So it's really trying to create actionable intelligence from this. If we go then to the bit at the top, which cuts through all of it, is the human factors side. So again, this brings in some of the law and politics stuff, so motivations, international relations, some of the psychology side, so individual susceptibility. Why do people click on malicious links? Why do people respond to malicious emails? Again, bringing in some of the dynamics of dealing with pressure situations, and are people more or less likely to be vulnerable to cyber attack in pressure situations? And it also brings in some of the criminology side of it. So from a machine learning perspective, for example, if we detected an attack, how do we unpick machine learning algorithm to pick out the elements of the data that were used to make a decision and try and relate those to why somebody might be doing it from a criminological perspective, for example. So hopefully that gives you a little bit of a flavor of some of the research that we do. That's certainly not everything, but that's a little bit of an overview. I'm not going to go into too much of the other stuff, apart from to say that the funding that we have received is from both the Engineering and Physical Sciences Research Council, so your comp-sci type stuff, but also the Economic and Social Research Council. So, you know, it shows that we're genuinely generating funding to work on both socio-technical and technical problems. We're quite well linked into the rest of the UK. So PETRAS is the National Centre of Excellence for IoT Systems Cybersecurity. So we're quite linked on that side. And I know that you know, one of the questions with doing a PhD is, you know, how is it going to benefit me getting a job? Is it just about being an academic researcher? It's one pathway into being an academic researcher, but it's also a pathway into being an industry researcher. It depends which way you want to go. What we do is we bridge that quite well. We've got a very strong link with Airbus. We're also developing links with others such as Admiral, BT, Thales, in terms of our research and its applications. So we are Airbus's only global center of excellence in cybersecurity analytics. So cybersecurity analytics being this fusion of AI with risk and cybersecurity. We've done a load of work with them over the years. We've had PhD students funded by them and go on to be employed by them. We've had research projects funded by them. And ultimately, the research that we've done has now been translated into Airbus. They're using it now to protect their systems, and they've created a spin out as well around risk assessment. So it's very much foot in both camps. It's not just research for research's sake. This is really, you know, cutting edge industry applied research. So that's enough of that one. I'll just give you an example here of what I was talking about earlier. So I mentioned the recurrent neural networks for malware detection. So if you look here on the screen, this is an example of how we're taking machine statistics. So each of those nodes that's flashing there is related to CPU, network traffic, processes on a machine. We're collecting all this data, which is what's going across the screen now from the machine. And we're building the neural network to tell us how likely it is to be malicious or benign. If you look at the right-hand side, you'll see there every second, the neural network is predicting whether this is malicious or not. And at the end, it's telling you, it's, for example, here, 99.8% sure it's malicious, and it actually was malicious, but it told you that within 1 second. So what we're actually able to do then is to take this forward now, and this was actually done by a PhD student sponsored by Airbus. Within 4 seconds, we're able to not just predict that it's malicious, but when it's malicious and clearly malicious, like this example is showing us, we're hooking the underlying processes on the endpoint. So this is Windows 10 OS, and we're killing the underlying processes. So we've actually managed to take ransomware, hook the underlying processes and kill them, and reduce file encryptions by 88%. And all of that done within 4 seconds of the ransomware starting. So you could see, you know, this has got real applications for, well, take the WannaCry example recently, massively problematic, particularly in things like healthcare. This could have, you know, had a massive impact on that. So this is the kind of stuff that we do. Right. So just to give you another example of how we are sort of, our research is impacting outside of the university. In 2019, it's been a bit of a quiet one in 2020 because of COVID and lockdown. But to give an example of what we did in 2019, the NCSC CEO and Chief Operating Officer visited Cardiff. We were talking to them about the research that we're actually doing, and have held subsequent follow-ons about how our research could help them. So that involved our PhD researchers. So obviously that, you know, that's showing that we're directly liaising with the national lead on cybersecurity, and obviously our PhDs are getting exposed to that kind of network building as well. Our work with Airbus led to the launch of CyberLab, which is the pictures that you're seeing on screen here, the two on the left, or one on the left or one in the middle, of the launch of CyberLab. The guy standing to my right in that picture is the Airbus CISO, and the guy standing to the right of him is Ken Skates, who's the Welsh Minister for the economy, essentially. So, you know, really closely related to policy-based and industry-based activities. That's an £8 million launch fund. The demos there were built by PhDs and researchers at the university, and this is on site at Airbus. So, you know, it goes to show how closely aligned our research is to research and innovation. Myself, I was seconded to Airbus for the last 3-4 years, leading AI for cybersecurity. We've also now branched out into human factors research. So one of the profs in human factors research and psychology is leading the Airbus Accelerator for human factors research. So this is really looking at the susceptibility of individuals within the business to fall foul of cyber attacks, but also why people do and do not adhere to cybersecurity policies, which is obviously a massive thing for you know, a big company like Airbus. You know, the European footprint, I think, is 139,000 people, so it gives you real access to massive scale IT, but also people infrastructure. So as I say, this is really showing, you know, some of the hands-on research that we're doing. These are our demonstrators, you know, being demonstrated to big industry and to also to, you know, to key policymakers. This year we have managed to get an investment, £1.2 million investment in a cyber range. You won't have seen it yet, but the old Mac lab in the computer science department has been taken out and we're turning it into the cyber test bed. It's not quite as grand yet as that bottom right hand screen would suggest, but it will be along the lines of but very much a cyber physical test bed. It's got a smart city in there now, a railway track. We're about to acquire some mini manufacturing plant machinery, which will be a sort of mini robot arms conducting a robotic manufacturing process. So very much on the physical side. We've also got a cyber range in there. The cyber range allows us to basically build large scale digital infrastructures or digital twins of you know, large enterprise networks, smart cities, etc. That example that you've got in the top right hand corner there is an example enterprise network. What it allows us to do is to basically drag and drop virtualized infrastructures, so VMs, but also the networking infrastructure, to build representative real world networks onto which we can deploy things like ransomware type attacks or other type of network attacks, and we can play those out for real. We will then have screens, one of which is like, if you imagine a Google Street View of the university, and you can zoom into all the buildings, you can see the IT infrastructure in all the buildings, and you can again see how attacks play out in real time. This allows us to then deploy some of our AI technology so we can show how attacks are stopped in real time as well. We will have something that looks like the picture in the middle there, where you've got the screens on the wall, real-time SOC SIEM type scenario, where we can do some training scenarios, both in terms of how to respond to cyber attacks, but also how to set up infrastructure. Hopefully we'll also get to look at how people respond to cyber attacks, look at some of the human factors elements, for example, how people communicate, how people collaborate, how people deal under stress. We've also got eye trackers, so we can look at where people are looking around the room, and also in terms of what information they're looking at and how they're using that information and how they're responding. So it's a real step change for us in terms of ideally this will be student projects we'll be able to do in there, but also some of the other research we'll be able to do in there. So this will, this is a very, very exciting step change for us, and particularly for our researchers going forward. Ideally, over the next year, we are looking to create a space that does look like something on that bottom right-hand side. So it'll be very much more large scale and, immersive, if you like, research and teaching. So going forward, in terms of the stuff that we're likely to be working on next, so I mentioned earlier Epsrc, which is the National Centre of Excellence for IoT Systems Cybersecurity. We're heading up the safety critical systems side. So we're looking at doing some more IoT-based research around practical hands-on merging of IoT with things like factory floors, with smart cities, etc. Looking to increase the size of that cyber physical test bed, but also linking more closely with people like Thales Endec, who are up in Ebervale, who are growing very much an operational technology footprint there as well. So we'll be looking to expand on that. We're looking to move more into the genuine AI side, so automating cyber responses. So if you detected a cyber attack, how do you build AIs that can respond in a suitable, appropriate way, that can also, or where we can also dig into some of the algorithmic decisions. Why is that attack being blocked in that way? Why have you chosen to defend in that way? So, for example, it might be blocking, killing processes, automated patching, you name it. But also we're very much interested in the human factor side of it again, why people trust or they don't trust algorithms, how you can sort of create this harmonious merged world where you've got AI doing stuff, but also alongside security operations centers where people are, ultimately responsible for that decision, and how we move towards that sort of merged environment, which would be really interesting. We're also looking, as I said, to create this sort of hub, cyber innovation hub, which I think will be a unique physical location where we'll have all that test bed stuff I just mentioned on the previous slide, alongside startups, incubators, and accelerators. So we're looking at working with people like Tramshed Tech and Alacrity Cyber on this. And what we're really trying to do is align our PhDs to spin outs a bit more. So we found over the last few years that we are getting some really cool stuff coming out. And I think what we're trying to do is create that process where not everyone's PhD will turn into a startup, but that there is a clear opportunity and trajectory for people who are doing PhDs to have early stage mentoring and support, so that they can basically get a flavor of what it means to do a startup, and give them the support they need to, I feel like in their last year or 2 years of their PhDs, they think about what a startup might look like. Alacrity are also really good in that they actually build a team around an idea. So it doesn't even necessarily mean that the person doing the PhD is a front person, if you like, for the startup. They can maybe take a technical role on while other people are brought in around them to grow this business. So the overall ambition here is to grow the number of cyber businesses in Wales, right? Is to create them, improve the number of startups, increase the number of startups, and make this sector really vibrant. And again, a unique selling point being that we've got the university activity so close to the incubators and accelerators. And you imagine not just the PhD students, but also going forward master's students and undergrad students being part of this as well. So that's our sort of next step ambition. Right, so just to touch on why I think, as I say, Amir and Irene will come in later to talk about their perspective of why they think it's good to do a PhD. My view, because really you're getting the opportunity to work with world-class researchers on real world problems, right? We are genuinely solving world impacting problems. I mentioned WannaCry earlier. We've developed an early stage detection solution to ransomware using recurrent neural networks, which works. Could it itself be a spin out? May well be yet. Get yourself skilled in basically designing experiments and executing them that brings this two worlds together of latest technologies, AI, but also, future digital technologies, and how they link to how people think and behave. So understanding how to integrate new technologies with people, understand how new technologies are used by people, and understand how they're exploited by people, and how we can sort of use that behavior to better detect those sort of misuses. I think personally you'll learn a lot of transferable skills that will set you up for a career in academia or in industry. So you'll hear from Irene and Amir later, who are who are following the sort of academic route at the moment, but actually very much in a hands-on way, in a very much a practical way, so not a traditional academic route. But in the picture here, you can see Matilda. So Matilda is just finishing her PhD as well, sponsored by Airbus, and she's presenting the work I was talking about here at CogX, which is probably the UK's biggest conference in AI. And she's now gone on to be a research engineer at Airbus. So she's learned the skills to move into industry as well. Irene and Amir also work with industry and have also got the skills they could have moved into industry if they want or could do in future. So it's very, very much, as I say, not an academic only post. We're very much focused on applied problems and skilling you up ready to move into whichever sector you want to move into. So the last question, and I guess, will be how you move into doing a PhD. So we're quite fortunate at the moment to have just been awarded an Epsrc doctoral training hub in cybersecurity analytics. So we'll have at least 5 studentships. Actually, that's probably going to be 6 at least now, which is basically stipends and fees paid for 3.5 years. The idea is that it's cohort based. So all of those 6 students, what we're going to try and do is create diversity, both in terms of individuals, but also in terms of topics, but set up, if you like, a seminar series and a set of activities that allow you all to learn together. So this will happen across 2 cross-cutting pathways, which will pick out projects around both beneficial and adversarial applications of AI in cybersecurity. So quite algorithmic approaches that will try and use AI for good, like this ransomware example, but also use AI to disrupt So I'm sure you've all seen examples of adversarial uses of AI to, for example, confuse an image classifier that is driving an autonomous vehicle, to misinterpret a stop sign and drive through it, for example. The other side of it will be the human factors in cyber. So the human factors, cognitive psychology, neuroscience, criminology, sociology, asking the questions around the trust, why people would trust an AI in cybersecurity context, how people would work with a blended AI detection environment and security operations center, etc. The possibilities are pretty endless, across that. But hopefully that gets across the point I'm trying to make, which is that these 5 to 6 students will all come from different areas, and they'll be questioning and quizzing each other as to the benefits and limitations of each other's research, and ideally all leave with a very strong understanding and respect for the various aspects of human factors and technical elements of the future of cybersecurity and digital solutions. So they will be opening up early next year. So if you've got any interest in that, obviously, shout as soon as you like, but they'll be coming out next year with a view to starting in October 21. So anyone finishing a master's or an undergrad next year, moving into 2021, they'll be ready to start then. So that's it in terms of my slides. So I'm going to stop sharing my slides now, and in fact, stop sharing my screen. I'm going to answer a few questions now that Irene sent over. Irene's got some Mentimeter stuff she'll put up now.
Do you want me to put the Mentimeter now or at the end?
No, go for it now. Go for it now, because people can start filling it in while I'm talking around the questions that you submitted.
Can you all see my screen?
Yeah.
Cool.
So if you go on menti.com and you use that code at the top, 802429, you can just participate. Well, we have a couple of questions, and that's the first one. So out of curiosity, we would like to see how many of you are interested in doing a PhD. So feel free to, give your response.
Cool. Okay. So was there another one to put questions in as well?
Yes, but we can't have both of them at the same time.
Yeah. Okay. Fine. Okay.
So we need to wait for a couple of seconds, and then I'll move it to the next slide.
See, we got a lot of maybes here, right? So that's good. So I want to try and convince these maybes. Can you change your answer so we can move them to yes towards the end? Or no, maybe. Well, we'll see. Right. So I'm just going to run through, have a think about any other questions, right? And we'll capture those in a sec. I'm going to run through questions that Irene sent to me to talk through. These are questions that she thought she might have answered if if she was in the room right now. So first question is, what do I need to pursue a PhD after a BSc? Is an MSc necessary? So no, it's not. Normally we look for a 2-1 BSc. You don't need to have a master's in it. You don't actually need to have a master's in anything to do with cybersecurity either, or a BSc in anything to do with cybersecurity. What we're looking for is a range of backgrounds, actually, and a range of interests. It would be advisable that you have an interest in cybersecurity, though. I'm sure you wouldn't be on this group if you didn't. But we don't necessarily, for example, you don't need to have the computer science with security and forensics. You could come straight off a comp sci degree, but you could also come off a psychology degree, but have an active interest in the cybersecurity side of it. How can I find a topic was the next question. So we will be publishing some topics through the scholarship, through the Doctoral Training Hub. But generally, what we ask when applying for a PhD, if you were to say be self-funded, is to get in contact with some of the academics in the team. They've all got web pages. Identify areas that interest you and work up an idea with them so that you sort of hit the ground running. That's a good question. The next one leads into, how do I approach a potential supervisor? And from your perspective, what qualities are you looking for students to have? Good question. So you can approach the potential supervisor just by emailing them. Generally, they'll tend to reply. The qualities we're looking for students to have is basically independent thought and an excitement for it. I tend to not be specific in what I'm looking for a topic. I want the students to come in with clear ideas, and from ideas I mean not I'd like to study AI in cybersecurity. It's what specifically do you think is a research problem that you could dig into, And even better, if the qualities of a student is to have independent thought, is to have dug into some of those questions already. You know, and really, you know, come to me by saying, I've looked at some of the stuff that's out there. I think this is a bit of a limitation, and I really like to dig into this particular topic. And I can help you shape that, and the other guys on the team can help you shape that. But it's really enthusiasm and energy and excitement for the topic, right? Yeah, this is key. What if I discover I really dislike the topic I initially had in my head once I start the PhD? I guess that is the next question. Fine, that happens. Not a problem, really, to be honest. You know, it's a 3-year project. So we, within the first year, you're looking to shape your ideas. You're not committed to that idea forever, right? It changes, it evolves, it morphs. I've had people change completely, right? It doesn't really matter. But the important thing is communication, that you flex around that topic, you make clear to people, you know, supervisor, it's not working for you, and we can kind of work around that. You know, it's not like you've got this sort of contract that you've signed and you're stuck on this particular topic forever, right? We can move towards that. Next question is, what experience do I need for a PhD? None, really. You can come straight off a BSc. You know, we'll teach you all the stuff you need to know about research. The experience you need is really just you know, an excitement and an interest in the topic. But as I said, a bit of background helps. You know, understanding, you know, what some of the key problems are will help. Next question is, what about funding? So definitely there are some opportunities coming up, as I say, 5 or 6 of those. So they're there. They are, I need to look into this a little bit more, but previously they are Epsrc studentships. So that means UK Research Council. So typically UK Research Council is UK taxpayer money. So they like the applicants to be UK based. Previously, though, they have allowed EU people to be funded through them if there's no quality UK applicants. Honestly, I don't know how that'll change. That's going to go one way or the other. That could be that EU residents are not allowed after Brexit, or it could go the other way, which is that basically anyone from anywhere in the world falls into that category after Brexit, i.e. if you can't find someone in the UK, you can include an international student. I don't know is the answer. I'm looking at that at the moment. So follow up on that if that's still a question for you. How can I increase my chances of getting a scholarship is the next question. So there's the opportunity here is to try and get a decent final year project on it. If you're already interested in doing a PhD, then you've got an opportunity now when you do your final year project to link it to a PhD. So start thinking about, how can I turn this final year project into something that I could follow into a PhD with? So, you know, Irene's helped some people do this recently, where she's actually worked with undergrads to do their final year project. They've published a paper out of it, and then they can kind of move into the PhD sphere from there. So that's a good way to think about it. It's also a good way to think about whether it's for you. If you think maybe I'll quite like a PhD, but I'm not sure, and doing some stuff that's researchy around your topic is a good one. Next question was, what should I expect from my supervisor? So your supervisor will not come up with the ideas for you. That's the main principle here, I think. It should be you leading it. So your supervisor will help sanity check those ideas. They'll help you learn how to do research, how to do the lit review, how to shape and frame your ideas, how to design your experiments, how to plan your experiments, how to execute them, how to do data collection, analysis, etc. They'll teach you how to be a researcher. That's, I think, what you can expect from them. Next question is, what if I'm really interested in both the topic and research, but feel I'm not good enough to apply for a PhD? I just ask the question. You know, we're here to help, right? I just basically say, let's have the discussion. If it pans out that, you know, you actually don't think you've got the interests after we have that discussion, then fine. But I would say, just don't feel like you're not good enough. There's no such thing. You know, let's have a discussion around it. And the team are very supportive of trying to flesh out some of your strengths and limitations, and then have a reasonable discussion and conclusion as to whether you want to pursue it. Next question is, what does the PhD really involve? I'll defer that actually to Amir and Irene when they come in. But from my perspective, it's about framing real world problems and designing experiments to get your teeth into them and identify answers to those real world problems. So the next question is, why would you choose to pursue a PhD when you can go into industry instead of start earning money? Good question. So I would say that I mentioned earlier about some of the transferable skills that you develop. I think, we actually tend to do a lot of our stuff with industry anyway. The bottom line is that you will build your networks through the PhD, and you'll build your experience through the PhD, and you'll build your skill set through the PhD in a way that might actually end up jumping up the ladder. In terms of if you say go into a graduate role, you might spend 2-3 years doing that graduate role, and then obviously get bumped up the salary scale. But it's the same principle with a PhD. It's almost like a graduate thing. The entry level for people moving from PhDs into posts are pretty high salaries. They're number out the air, 55, 60K. I think people are coming out of PhDs on now and going into jobs on, which I think probably if you went straight from your degree into a graduate role, it'd still take you 3 years plus to get to that sort of level. I know there is a little bit of a view at the moment. You command what you like in the sector, but actually there is a little bit of pushback from industry on that. They do want experience, so this is a way that you can get hands-on experience in an area that gives you freedom, if you like, to explore. So it is a very good alternative to going straight into industry. Next question is, what other activities can I do during my studies to earn money? So you can take on teaching associate roles. In fact, the school, I think they're closed now, but for the last couple of years, they've offered teaching associate roles, which are a decent, basic salary, where you do teaching, obviously, but that you can also do a PhD at the same time. So these are good little earners. So the next question is, why study at Cardiff, which is a big question, but hopefully I've kind of given you a unique flavor of Cardiff in that we've got very applied perspective. So they're not theoretical PhDs for the sake of doing research. We're solving real world problems and working with real world partners, as for example Airbus, but I mentioned earlier some of our other partners we're working with as well. We've got some really top class infrastructure coming from next year, or in place now this year, in terms of the cyber range, the cyber physical test bed. So we've got some really strong stuff coming on there, and also our move towards startups and spin-outs. So I think the next cohort of PhD students will have a unique opportunity to work with accelerators to try and turn some of their stuff into products and spin-outs. So there's some really unique factors there. Okay, so that's the end of the questions here. So I would like students, so Anna, I'm just looking at Irene's email now. Students to answer some questions from a student's perspective. Why did we choose a PhD? I think that's some of the stuff that Irene and Amir are going to answer. So I'll shut up now, I think, at this point, and hand over to Irene.
Okay. Hello all. I don't have a presentation for whatever I'm about to say, but well, I guess it's going to be okay. So my name is Irene, and I'm a fourth-year PhD student in Cardiff, obviously. I actually just submitted my thesis, so I'm almost done with it. And my research revolves around the security of Internet of Things and industrial control systems, and specifically how we can use machine learning algorithms to build more intelligent intrusion detection systems for these networks. Now, everybody's path and experience in doing a PhD is completely unique and different. But today I decided to share mine with you because you might find it useful and because some of you might relate to my path. So first of all, I should probably discuss why I chose to do a PhD. Well, I always had in my mind that I would like to pursue one because I consider myself to be a really curious person. I always ask why, and I always try to think of other ways that we can do things, or other ways that we can do things better. And although that was the case, I wasn't sure about the topic that I wanted to pursue. And until my third year, I was really interested in both computer vision and cybersecurity. Now, what really helped me decide was my involvement with research-based projects, such as Europe projects, and most importantly, my final year project. So the Cura project is a very good opportunity to contribute to a greater project. We actually have an opportunity coming up next summer. So I'm not gonna give you now the details, but keep an eye out for them. And the second and most important bit was the final year project, as Pete already mentioned. So this was the first bit of research-based work that I had to conduct by myself. I had to identify a problem, obviously with the guidance of my supervisor, but it was mostly me leading it. So I found the problem, I designed an experiment, I had to collect data, I had to write the tools to analyze that data. And in the process, I actually found some really interesting results and some unexpected results. And when I got the feeling, the satisfaction from doing this, I knew for sure that research is what I want to do as a job. I can't really explain that feeling. It's just awesome. So after this, I had to jump onto a PhD program, right? And I graduated with the first class honors, which allowed me to apply straight for a PhD. I didn't go to a master's. Now, then things got a bit tricky because I applied for the school scholarship twice and I failed twice. It's a very competitive program. So I assume at the time I wasn't ready for it. But I didn't give up. I really was determined to do it. I knew that this is what I wanted to do. And I started my PhD being self-funded for my first year. And it was hard, but I really enjoyed the research. I actually managed to publish a paper and I went to a conference within the first 6 months and I won the Best Paper Award and I was just hooked. It's like an addiction, publishing and discovering new things, I guess. So after this, and with the help of Pete, who has supported me since then, I managed to get a job as a research associate on a project funded by Airbus. I should say that being self-funded, it's okay if you don't have any other option, but it can be incredibly hard, not only financially, obviously, but mentally and physically. I had to do lots of labs and tutorials to support myself. So try and get a scholarship or some sort of funding if you can. So going on to that array project with Airbus, that opportunity was even better than getting a scholarship because it exposed me to things that I never dreamed of previously. Like I got to be on Airbus's site, I used their equipment, their testbed. I went on events, I traveled so much to different places and I met so many different people, both from industry and academia. And this is really a unique opportunity. I had the best from both worlds, really. So I can't really describe that any better. So thinking and reflecting about my journey so far, doing a PhD and at the same time an array post, it was incredibly challenging, but also rewarding. Luckily, my array post with Airbus aligned perfectly with my PhD objectives. So for example, my PhD was looking into Internet of Things or machine learning based detectors for Internet of Things. And Airbus's project was doing exactly the same, but it was the application of it was in industrial control systems. So in a way, I could use the tool that I developed for IoT and test it into Airbus's infrastructure. So it was a win-win situation. So the PhD is challenging because it's a constant problem-solving task. You constantly have to find a problem, analyze it, and see if you can come up with a solution that it is better than whatever is already out there. And on top of that, you have to justify yourself to other people. You have to justify why your method is better, more efficient. You have to prove that it is novel. So it's like a constant fight. But then it's a great opportunity at the same time, because every time you do that and every time you develop something new, you get to push the envelope of human knowledge a tiny bit further. And I think for me, this is what makes me excited about doing a PhD and research. You get to do something new that no one else has done before. And yeah, how else can you describe this feeling? And you also get to learn not only technical things, But as Peter already mentioned, are the transferable skills. So throughout my PhD and my post with Airbus, I had to learn how to present to people. I can't even count the number of events I participated over these past 3 years. I had to really push myself and do things that pushed me away from my comfort zone, and that helped me grow. It helped me critically analyze everything. I'm not sure this is a good thing in your everyday life, but it's a great skill anyway. So yeah, I learned so many things and I grew as a person overall. So a PhD, or if you ask me about my feelings about my PhD, I think I would say I have a love and hate relationship. I don't regret it at all. I would do it again. And now we have amazing equipment in the university. We have an amazing testbed, HoloLens staff, AR staff, cyber range. And so the new people that will do a PhD will have the chance to get their hands dirty with all this technology. When I started, I didn't have an IoT testbed, so I had to put that together from scratch. So yeah, you're in a very good position to start a new PhD if that's what you're interested in. You will feel like you want to give up at times if you choose to pursue one, but if you have a great supervisor, like I was lucky enough to do, you will get through it, and yeah, you will enjoy it eventually. So if I have a couple of pieces of advice for people that are consider doing a PhD, I would say pursue a PhD if you're curious in general and about a specific topic, and if you're passionate about it. You have to be prepared to do a lot of hard work. You have to be prepared to be pushed out of your comfort zone, and you have to enjoy the challenges. It's every day you will have to face something new. And of course, last but not least, you have to enjoy learning new things on the fly. Like today, you might look on one thing and next week you might have to learn something completely different. And I also, on the same note, I would say, think twice about pursuing a PhD if you're only doing it for money and for prestige because it sounds cool to be a doctor. And of course, if you're not 100% sure about the topic, if you're not really interested, because in that case, I think a PhD would be a torture. So yeah, of course, in the end, you might end up having a really good job with a lot of money and having the prestige as well, but that's not going to get you through what you have to do through your PhD program to reach the other end. So this is all from me, and I hope that you found that interesting. I'll pass it on to Amir now.
Thank you, Irene. I've got a couple of slides, so I'll just, I think if you can stop sharing a screen, Irene, I'll just share mine.
Yeah, sure. Let me figure this.
Okay.
Share. Okay.
There we are. I think. Just. Okay, is my screen visible?
Yeah.
All right, so I'll start up with the question that I have, similar to what Irene is. Why did I wanted to do a PhD? And like Irene did a transition directly coming from bachelor's to jumping into PhD and realizing that she really liked doing research while she was exploring some projects related to her BSc. So for PhD happened to me while I was doing my master's. And at that time, to be very honest, when I started doing master's, I wasn't planning to do a PhD. And even though I was thinking maybe I'll finish my master's and I'll go directly into industry and I'll start probably get a job related to security. And the whole turning point happened when I started doing my master's project. The project itself turned out to be so interesting, and I felt that, and I, like Irene said, like you really get hooked onto it and get addicted the more and more you keep on digging into the topic itself and find there's so many things that you can do, and you can actually build something out of it, which could create a tool or a software which could actually have a real life impact on a real life problem that you would be tackling. You could potentially do that. So at the time of master's, I was actually looking at to see whether attacks could come. There could be certain attacks that can come from cybersecurity, and it enabled me to build a honeypot, start collecting data from the Twitter itself, and trying to see whether attacks are actually happening or not. This whole process made me actually fall in love with the research itself. So I thought, like, why not? Let's see if I can pursue a career, or if I can pursue a PhD, or I can see if I can something move forward with. And we had a conversation with Pete, and we said, like, okay, there is still a lot of scope that is there. We can do it into, and let's try to see if we can move or convert this master's program, take it forward into a PhD. I had another slide. Just wanted to see how many of you guys think like online social networks such as Twitter could be used to carry out an attack. So that was actually kind of the basis on which we wanted to build upon. So at that time when I was starting to do my master's, I actually did not know that you could use Twitter or any online social network to actually carry out very difficult attacks or even very dangerous attacks. But I like I said, you cannot just pick up all the attacks that are there. You cannot focus on everything that's there. So after speaking to Pete and after speaking to the supervisor, we decided let's narrow it down to certain topics that we could be doable or we could have some research onto it. So the topic that I was particularly interested in was attacks such as driver download attacks that are coming from Twitter. So I'll give you a brief overview what my research was about. So this slide basically summarizes my entire PhD in just one page. So it all starts by creating a very interesting or a catchy tweet, something like hashtag Star Wars checkout behind the scenes pictures, and then you inject a small URL to it. So the idea behind this tweet is the adversary or the attacker is trying a catchy tweet or a clickbait for you to click on the URL. And the moment you click on the URL, you get redirected to a malicious web page. And as you're observing the malicious web page, you've got a malicious JavaScript, which is embedded into the malicious web page, which gets executed on your screen, on your computer itself, which exploits a vulnerability and injects a malware into your computer itself. But the important part of this attack is that the action that you only did was you visited the web page. You did not click on anything on the web page itself. You did not download any software. All you had to do was visit the web page itself. So while I was doing my master's, I thought like, this looks really interesting, and let's see what kind of attacks exist on Twitter itself. How are cyber criminals trying to use Twitter itself to carry out these attacks, and what kind of percentage of attacks that are happening? And we found that like sporting events, which are quite popular, there were I think around 10% of the tweets that were tweeted around sporting events actually contain these kind of attacks. And then I was like, okay, we know that these attacks exist. What can we do about it? Can we find some indicators? Can we find some indicators so that we can prevent these attacks from happening, or can we identify before these attacks are carried out? And which lead me to my whole research problem or my PhD and trying to research in that area, where I wanted to look at the social aspect as well, which is the users who are posting these tweets, what kind of friends that they have, what kind of followers that they do, what kind of content that they're posting, whether it's like around certain sporting events or whether they contain any emotion or sentiment. And then also look at the machine features as well, such as how your machine's state is changing the moment the URL gets clicked and the moment the attack actually happens. And can we combine all that together to build a machine learning model which can actually predict that the attack is going to happen if you click on this URL? And so that you can create a system so that you can stop the connection before an attack is completed. So that was the whole research idea for my thesis. So yes, so just to give you an overview, like just to touch upon on the funding side of it. So once I wrapped up my master's thesis, I I applied for an RA position in the university itself, and which gave me an opportunity to fund my PhD as being part of the staff in the university itself. I didn't apply for any, I think, funding opportunity at the time, because I think that was not, because I already had secured a job as an RA at that time. So I think Irene went to that path as applying for a scholarship, but I was lucky enough to get the research post. And the other interesting part is to find a supervisor who's interested in your topic as you are passionate about it as yourself. So it will really help you shape your thesis very nicely. Okay. So at the end of it, I submitted, I think, my PhD a year ago, and finally got my, I think, did my defense this year and had my PhD. And what I really got out of my PhD, it gave me a flexibility to work on a topic that I was really passionate about. So you could define your own working hours. You can spend as much time as you want on a topic, go as deep as you want to. There's no limitation to it. You can just explore the whole topic as much as you want to it. It gives you an opportunity to collaborate with colleagues from other university. You can even collaborate with colleagues with university overseas as well. You can, while you're working as an RA, it gives you an opportunity to work with people in the industry, see what people in the industry are doing, and use those skills and learn those skills, and then you can actually apply them in your PhD and get something really good out of it. It also gives you opportunity to go and work in conferences nationally and internationally. It gave me opportunity to travel to countries which I've never been to. That was also a thing that I thought would be quite interesting to see. This is something I wanted to say is, we have this conception like PhD is all about, constantly researching and publishing paper. It's not just that, it's more to it. It's about actually building something that you're passionate about. Yes, it is. It's more how I would look at it back is looking at a topic which I'm really passionate about. Papers, comes automatically out of it. If you've built something which is really good, and so paper will follow automatically out of it. It is not about working in isolation. You could actually create your own schedule. You can work around it. And there are times, like if I'm stuck on a problem, I'll just go on Irene and say, like, look, Irene, I'm stuck. Can we just, go for a coffee and let's solve this thing and see what's happening over there? I can pester her about that, or I can go somebody else is like, okay, tell me about your research, what's going on over here. I think I can't do anything, work on my research. And at the end of it, something good will come out of it. You'll get an idea which you can apply on your PhD, and maybe some like a new good paper will come out of it, or you can push it into a journal, or you can look into a topic which you are completely not thinking about it. And I think that's it from me.
I think we have some questions now on Mentimeter. Should I share my screen again?
Yeah, I'll stop sharing mine.
I think they are for Pete. I don't know. Yeah. Okay. Can you see the questions?
Yeah, I can see them. Okay, economic comparison. So I guess that's salary difference between PhD and non-PhD once in the industry. So I guess entry level with a PhD is probably higher than non-PhD, but of course it takes you the time to get the PhD. So you're not earning at that level before you've got it. I think different. I wouldn't necessarily base it on the economic comparison. I would base it on the type of role you want to go into. I mean, the role that a PhD would normally have would be future looking, I suppose, is where I would put it. It's the people who go with PhDs into roles are likely to be looking at future directions, strategic directions, future tech, next steps of a business. So it's more about what you do in the job rather than just about the salary. I mean, naturally, then as a strategic thinker, or people looking at the future tend to demand a higher salary, but you probably end up on par at some point or other. I don't think economically it'll make too much difference. Hopefully that answers that. More flexibility time-wise, yeah, absolutely. Part-time PhD is perfectly doable, feasible. Not a problem at all. Normally, a PhD funding is 3 to 3.5 years. If you do it part-time, it's 5 to 6 years. So that absolutely perfectly likely. It shouldn't make a difference at all in terms of funding, because the options for part-time and full-time study are there. Currently first year, there's still approximately 2 years to finish, still interested in helping learning more. Okay, so what I would say then, if you're interested in learning more, is to do more active stuff yourself. Think about what you could do. Take more interest in, like, reading blogs, attending webinars that are sort of future looking, challenge based, that kind of thing. Join open seminars and discussions that are around cyber and the future of cyber. There's plenty of those advertised on Twitter at the moment, particularly with COVID. And just keep an open mind, I would say, and then when you at the end of your or when you go into your third year, start thinking about how you might tailor a project to this if it's still of interest. So yeah, I wouldn't expect anyone at this point to be thinking. Generally, I would say, as a rule, I don't think any of the students that I've ever supported through a PhD would have been in their first year or second year or maybe even third year thinking, yeah, I want to do a PhD. It tends to be something you sort of hone in on towards the end of your studies. So just keep an open mind on that one.
I would like to add that Europe is a great project to get involved if you can find it. I think you can only do it if you're in the second year or finishing your second year. So, and any other small project that you want to develop for yourself, you don't have to just do whatever uni tells you to do, but you can do side projects in your own time, and that will help you understand what you like, what you don't, and so on.
Cool. Projects should have done beforehand, especially covering non-cyber. No, not at all. Just be interested, I think, is in cyber. I think one of these listening to both Irene and Amir talk, it's clear that they're passionate about the topic. So it's sort of clear to me, therefore, and I think Irene's message was clear, that you need to be enthusiastic and excited about this topic before you enter it. So that, I would say, is a project in itself. Read around the topic, look at some of the interesting resources that are out there, and judge for yourself how enthusiastic you are about it. Large intake per year. Oh wow. So it varies year on year. I mean, this will be a bumper year for us this year because we'll be taking on at least 6 new cyber students. I'd say probably 2 or 3 a year normally. The overall intake in the school is probably bigger. Obviously it's a lot bigger, but actually no, I could probably put an estimate on it, because we have an annual poster day where the students all present their work, and it's probably around 30. So I'd say probably about 30 students per year coming in. And then anywhere between 3 and 5 of those are normally cyber. We've got a bumper year this year. There'll be 6 plus the normal intake. So could be 6, 7, 8 this year. Doing it alongside working within industry. Yeah, absolutely. This is something that your industry sort of, well, your boss basically within industry would have to be supportive to give you the time to do it. But as I said earlier, same response as the needing more time for any reason, really. Flexibility around disability or childcare requirements, or anything to do with learning capability or working with industry. We can accommodate all of it part-time, not a problem. You just need to agree with your industry supervisor that they're happy to do it. One of the things you could do is to try and align your work in industry to the problem. I mean, that might get your industry supervisor on board. If you're actually studying things that relate to your work, that's happy days. That'd be really, really good. So it's worth thinking about how you can play the game in that respect. I think I saw a message just come in on the chat as well. Did I? Okay, no, that's the feedback stuff. Okay, cool. Please fill that in. Okay, so no more questions. If there are any more questions, add them to the Menti or put them in the chat. That's fine. Either's fine. I can answer those. Nothing more coming in. I'll just give you a sec to type those things in. So just generally as follow-up as well, obviously, if you are interested in, have any further questions, drop us an email. If you're interested in the scholarships, they'll be advertised the first quarter of next year, I would have thought, probably not January, maybe into February, March, with a view to starting in October. But this is, yeah, they'll be there year on year after that. Hopefully we'll have more scholarships year on year. Yeah. So I'm not seeing any more questions, and there's nothing coming in on the chat. So I think Amir, Irene, if there's anything else, if not, then I'll hand back to Jack.
Yeah, any more questions, guys? Feel free to get them over now while you've got the opportunity. But I'm sure that that any of our speakers today will be happy to answer a couple of questions. If you just want to send them an email or message on Twitter or something like that, I'm sure they'll be happy to get in touch. But yeah, if there's no more questions, then yeah, thank you all for attending, and thanks very much, Pete, Irene, and Amir, for your time this evening, for giving your talk. It's been really insightful, and I'm sure has helped a fair few students with their next sort of steps as they decide what to do. So yeah, thank you everybody for attending. It's been great.
Brilliant. Cheers all.
Thank you.
Thank you.